Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in this video we'll discuss about question number 29 NEET Physics paper 2016. Students, let us solve question number 29. A car is negotiating a curved road of radius r. The road is banked at an angle theta. So it is a case of angle of banking. This is the banked road and this is a curved banked road, and a car is there. Okay, suppose this is a car which is negotiating this curved banked road. This angle is theta, which is given, and the radius of this curvature, is r. R is the radius of curvature. R is the radius of this curvature, and the coefficient of friction between the tires and the car. So the coefficient of friction is mu s. Static friction. Coefficient of static friction. The maximum safe speed on this road is. So you have to find the basically safe speed, so that it will not skid or topple. So in case of a banking of roads, that the road is banked as well as the friction is considered, we have to consider all the forces acting. Now we have to draw the free body diagram of this and then proceed. First of all, this is the situation. The car is over here. So this is the car. Now its weight is vertical downward. mg will be acting vertical downward. The normal direction will be acting in this direction. This is the normal direction. Now in the case that the speed is very high, the car tends to skid away. So while moving or negotiating with higher speed, it tends to skid away. So friction will be in the downward direction. Okay, so frictional force is in the downward direction. Because we are interested in safe speed, this is the force of friction. It will be in the downward direction. Now we have to resolve this in the n cos theta, n sin theta, f cos theta. So we have to resolve everything in this directions. All the forces in this direction. That means in the parallel and perpendicular to the weight. Okay. So first of all, this angle is theta. So therefore, if I resolve this n into the two perpendicular components, then this will also be theta, and therefore this component is n cos theta and this component is n sin theta. Okay. N cos theta will balance the weight and n sin theta provides the necessary centripetal force. Now I have also frictional force which has to be resolved along this and along this direction. So if I resolve the frictional force in that direction, this along this direction and along this direction, because this is the frictional force. So if this is theta, then this is also theta. Okay. If that is theta, then this will be f cos theta. Component is f cos theta and this component will be f sin theta. This is known to you that if this is a vector, and this angle is theta. Its component with the side containing theta is cos, so it is f cos theta. The other one is f sin theta. Now, if this is the vehicle, this is the car, and in this direction there are two forces, mg plus f sin theta, and in the upper direction I have n cos theta. In the upper direction I have n cos theta, and in this direction I have two forces which are f cos of theta plus n sin theta. Okay, so this provides centripetal force, this provides centripetal force required for circular motion, because this has to be tangent. If this is the direction of velocity, so centripetal force will be towards the center of circular motion. Now, if I write those equations, that n cos theta balances mg plus f sin theta, or I'll write n cos theta minus f sin theta equals to mg. This is equation number 1. And this one will provide centripetal force. So I'll write f cos theta plus n sin theta equals to centripetal force, that is mv square divided by r. This is equation number 2. So from these two equations, if I divide equation 2 by 1, then I'll get right side v square by rg, and this side I will get something, and I have to solve this to get the safe speed, maximum safe speed, that is v is required, and out of this you will get one of the answers. So from here we have got two equations, and that two equations will divide 2 by 1, we will get dividing equation 2 by 1 will get, right side I am writing here mb square by r equals to, this is mb square by r and this is mg, so I will divide by mg, that is equal to n sin theta f cos theta, n sin theta plus f cos theta divided by n cos theta minus f sin theta, n cos theta minus f sin theta. So from here you will get m will cancel out, this side will be v square over rg, and this side it will be n sin theta plus f, this is the frictional force, f cos theta divided by n cos theta minus f sin theta. Again, the frictional force F is proportional to the normal direction, so therefore this is equal to mu s into n, the normal direction. So this F is always mu s into n. I'll write then n sin theta plus mu s into n cos theta over n cos theta minus mu s n sin theta. Here n will be common from upper and numerator and denominator, and they will cancel out, so this will cancel, and we are left with v square upon rg equals to this part. So this implies v square upon rg is equal to sin theta plus mu s cos theta, sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, cos theta minus mu s sin theta. Okay, Now from here v square will be rg bracket sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. And from here, if you see the options, it is under root of everything because v is required. So if I take v, then it is the under root of this part rg bracket sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. If you see the options, there is no sin theta cos theta, it is tan theta. So you have to write the solve it to in the form of tan theta. So I have to divide the expressions by tan theta. So if I divide cos theta in each of the terms of the numerator and denominator, then what I will get? That means I have to divide cos theta here, cos theta here, cos theta here, and cos theta here. So by dividing cos theta in the each terms of the numerator and denominator, we are getting this. So from here I'll get this implies v equals to under root of rg bracket starts sin theta upon cos theta, that is tan theta, plus mu s, this cos theta cancel out, only mu s is left, divided by the denominator, this cos theta cancel, 1 is there, minus mu s, and this becomes tan theta. So it is mu s tan of theta. So finally we are getting that if I write capital R, because the question is capital R, so it will be gr and bracket mu s plus tan theta divided by 1 minus mu s tan theta under root. This is the formula for v that I am getting here. If you see the options, then it should be gr. This is not gr, this is not gr, this will not be the options. This is also not the options. This is the only right answer, gr under root of gr bracket mu s plus tan theta by 1 minus mu s tan theta. This is not plus, this is mu s tan theta. Okay, so third option is correct. This is the right answer to this question. This is actually the result is a formula you have to remember, that the maximum shape speed is under root gr mu s plus tan theta divided by 1 minus mu s tan theta. Okay, thank you.